So, since I am forced into writing Rust for the um, short future at the release, but fully Rust, I kind of, try to think the ways to get better at it as quickly as possible. And in conversation, okay, I was mostly just, how do you say, forced to see these points, but a great friend of mine told me that mostly with Rust, it's all about just knowing the patterns, and in this specific case, it's often is even more valuable to just know theory than to have practice, because with like stupid programming languages, not stupid, but like not smart programming languages, where you cannot try to be too smart and shoot yourself in the foot. Um, it's most about practice, because there are not many things you can try, and you can just go through them all, see all the errors, and just learn from what not to do. In Rust, there are too many combinations of what you can do to attempt to learn from what not to do. So it's better to just figure out what patterns work in every single situation, because again, the split space is too high, too large, and there are great forums. For example, URLO, this URLO, URLO, something something. I'm not gonna look it up, but you should be able to find it. And like for questions, general questions, in a rather strict format, so it's similar to like Zulip. I'm not even sure it could be Zulip. Whatever, it doesn't matter. The point is that very structured conversations on topics that arise on like medium level, and I have no advice to just go through the questions and add the conversations on topics that I cannot give my answer to. And I've done it for like a few hours today. It's very good. I will continue doing it. Definitely learn a lot. And then another thing, there are some huge names in blogs industry, which I wasn't, I did not know before, which is kind of embarrassing. But there are Metclad, which is the guy for Rust programming blogs, and then boats, something about boats. I don't know, for some reason he loves the quotes about having the boats and seeing the future, whatever. I think it's like where's.boats. Also great blogs. But currently I've just taken the things that Matclad's been saying, and I have structured them in my .github. I will be linking this from all my repositories on the practices for structuring and writing code in general. And then there are like practices on every specific part of the code, but not in a block format, but in a structured format for every single thing. And like my interpretation of it is how I define it, and it's linked statically for all projects. So it's just a single source of truth on all the practices and so on. And then plus on top of that, I have a like quick init library, which I have updated today with some, because there are too many, of the best practices. So all new projects going forward are initialized with them, and I'm kind of forced into adding them, because there are some blank spaces which are disturbing, distracting, which are not nice if left untouched, but they're added by default with my initialization script. So I'm kind of incentivized to pay attention to them later. That's how I structure everything, because it's impossible to keep it in the head without great experience, and so I'm just forcing myself to think about them every single time. Um, Anyways, probably the most important the most important thing, which for some reason I didn't have it. Every single day I see how much of a bad programmer I am. I compare it to the absolute legends of the space. Again, compared to, doesn't matter. The rule is weirdly named not rocket science rule, which states that main branch should at all times have a working version of the code, and that the commits, pull requests, do it should be checked not only at the moment of submission of the pull request, but right before the merging, or rather right before the merging. And no branch can be merged to main without passing all the checks. And I kind of been lazy with writing tests, and I not really understanding them, so I know how to write good code in some cases, but it's much more difficult to write good tests. And it is incredibly important to write a good test suite for the project, and testing not units, specific functions or whatever. This is very bad practice, but testing the features, testing the data transformation, because this is fundamentally what the application is. If it's not if it's not doing something visual, when it's processing applications, which is mostly what I'm working with, it is just data transformation. So what you need to do is test the process of the data transformation. So there are some steps which are unchangeable or rarely changeable, like unlikely to change, and you need to just check at each step this works. Instead of testing individual functions, properties, whatever, because it makes it impossible to change codes. And I've been kind of guilty of this in some cases, and in some cases just not spending enough time to develop actually reliable test suite for the main branch, which I can run and be somewhat certain that the code works, all the code works, and instead I kind of have like separate tests all over the place. In some cases, insufficient tests for general integration, and this is something that I need to work on. And the approach of defining features and in this way on the main branch, which things that shall always run, kind of allows you to think of the code as a fluid subject matter, and you define a set of properties which it will have, no matter how the requirements for maybe not requirements but standards change. This set of properties is set in stone as long as the main branch exists, because it always passes all the tests. So you progressively add properties, just expand properties which are needed to be met for commit to be included in the main, and code becomes something of a fluid matter. Anyways, this gives a lot of freedom, I guess, in just working with it, and a lot more clarity in what should be done. And then there are some also great practices on architecture files. So I've never written specific architecture files. A great example of an architecture file is on Rust Analyzer. Read it, go find it, Rust Analyzer, architecture.md, incredible thing. So I kind of went through it, went for some hours, and constructed my own, and now just only having it makes it so much clearer what the project should do. So in a good architecture file, we just show the high overview of what the things do, of what files do, where you can find what projects types of code. So again, nothing low level, just the ideas of what parts of the code base, what part of the code base are meant to do, and what high level structures to operate with. So when you go to them, you can understand them, because that diminishes so greatly the time you need to spend looking for a code before being able to do commit. Because if you don't have that as a new contributor, you need to go through all the files in a random order, just trying to understand what it does. And here it gives the mental map which long-term contributor or maintainer of the project has already. So I'm just kind of sharing this map with myself from the future, or anybody else contributing, and this simplifies it greatly. And again, for myself too, apparently. So that's great. That's very important. Again, all the articles are on Matplotlib. It should be very simple to find. If you do programming, go read them. This is amazing. This is incredible. Extremely important. I also have compiled some of the things to my GitHub, but it's not even close to being ready. So don't even bother looking. Find Matplotlib and read through it again. Find URL Rust if you do Rust. Anyways, there's so much more to learn. I'll definitely do that.